Hi everyone, this is Anand and today we will be discussing the problems and solution of CodeDrift.
Hi everyone. So today in this video I will be discussing the problem bit compression. Okay. So in this problem we are basically given an array of n integers and we have to perform certain operations on the elements. Okay. And in any one operation we select two indices I and j, and ai is replaced with ai and aj, and aj is replaced with ai or aj. Okay. And both of these operations are applied simultaneously. Okay. What it means is that let's say if you select two indices I and j, and let's say the value at index I is 4 and the value at index j is 5. So a of I will be replaced by 4 and 5, and aj will be replaced by 4 or 5. So the new value of ai becomes 4 and 5, which is 4. And similarly the new value of aj will become 5, right? So in this way we apply a single operation on two indices I and j. Okay. And this operation is performed over all the pairs of integers in the array, and we have to find the bitwise XOR of all the elements after performing the operations. Okay. So if you are given n elements, okay, if you are given n elements, let's say these are your n elements, so you, for every pair of indices, okay, you basically perform this operation. Okay. And after performing all these set of operations you have to calculate the XOR of the resulting array and return it. Okay. So let us see how we can do this. So before this, let us see one example. For example, if your array is given like 2 1 3, let's say we took this simple example, then let's just first perform this operation over these two indices. So 2 will be replaced by 2 and 1, which will be equal to 0, right? And 1 will be replaced by 2 or 1, which will be 3. Okay. So the new array becomes like this. Now let's perform the operation over these two indices. Okay. Then okay, let's perform the operation over these two indices. So this will become 0, 3 and 3. And now let us perform the operation over these two, then it will become 0, 3, 3. Okay. So this is our final array, and if you calculate its XOR, you will get 0, because 3 XOR 3 is 0 and 0 XOR 0 is 0 again. Okay. So this is the thing. Okay. Now if you see in the problem, you will find that they didn't have mentioned any order in which you should evaluate the pairs. Okay. So there is no restriction that you should apply the first operation on these two indices and then these two indices and then these two indices. So there is no such restriction as this. You can just do it in any order. Okay. You have to do it over all the pairs. You can do it in any order, and finally you have to return the XOR of all the elements. Okay. So it gives you an hint that the final XOR doesn't depend on the ordering in which we perform the operations. Okay. So let us see how we can approach this. Okay. So let us say you are given two numbers. Okay. Let's say the first number in its binary looks like this. Okay. And let's say this is ai, and let's say aj in its binary look like this. Okay. So if you calculate their AND, so ai and aj will be equal to 0 0 1 0 0, and what will be ai or aj, that will be equal to 1 1 1 1 1. Okay. So the new value of ai will become 0 0 1 0 0, and similarly the new value of aj becomes all ones. Okay. So what you can notice here, that if you just XOR ai and aj, okay, if you calculate their old XOR, okay, if you calculate their old XOR, like XOR before applying the operation, this will come out to be 1 1 0 1 1. And if you calculate their new XOR, then new XOR will come to be 1 1 0 1 1. And if you notice that old XOR is equal to the new XOR. Okay. So what it means is that the operations don't change the total XOR of the entire array. Okay. So the XOR remain preserved. Okay. And you can also verify it, like since this is a problem of bit manipulation. So in a bit manipulation problem, always focus on each and every bit. You have to think bit by bit. So let's say if ai is equal to 0, okay, and aj is equal to 1, okay. So basically we are just taking any bit of the, we are taking the any bit of ai, okay, and we are also taking the same bit of aj. Let's say the some bit of ai is 0 and the same bit of aj is 1. So if you just replace ai with ai and aj, then ai will now become 0 and 1, which is 0, and aj will become 0 or 1, so this is 1, okay. So you see that their initial XOR was 1 and their final XOR is also 1, okay. Similarly, if you take ai is 0 and aj is also 0, then after applying the operation ai is 0 and aj is 0. Again their XOR before applying and after applying the operation is same, which is 0. Similarly, if you make ai is equal to 1 and aj is also 1, then after applying the operations ai still remain 1 and aj still remain 1, and hence their XOR also remain equal to this equal to same, so that is 0. Now the final case is when ai is 1 and aj is 0. So after applying operation ai becomes 0 and aj becomes 1. Their final and initial and final XOR still remains same, which is equal to 1. So from these it is clear that applying the operations don't change the XOR value, okay, don't change the XOR value. So more formally you can also write it like ai XOR aj is same as ai and aj XOR ai or aj, okay. So that's why the final XOR will remain preserved, and this is the only crux of the this was the only crux of the problem, okay. So all you need to do is to simply calculate the XOR of the entire array. So calculate the XOR of entire array and simply return it, okay. Now coming to the time complexity, calculating the XOR of the entire array will be order of n, okay, because you will just iterate through the array, okay, you will just iterate through the array and keep on XORing the elements step by step. And XORing, like whenever you XOR two things, like you XOR x XOR y, okay, so doing this thing is O of 1, so bitwise XOR works in order of 1, and doing it for n times will cost you order of n. So this will be the time complexity, okay. So this will be the time complexity, and the space complexity will be order of 1, because we will not be using any extra variable other than a simple variable for storing the XOR of the entire array, okay. Now let us look at the code. So in the code, let us assume we make a function int find, and this will accept a vector of integers, call it v. So first we find how many elements are there, okay. Let's say there is a we declare a variable, we call it XOR val. So initially is equal to 0. Now you just simply iterate through the vector I is equal to 0, I is lesser than 1, I plus plus. Simply say that XOR val will be equal to XOR val XOR v of I, okay. Or alternatively you can also write it like this, that XOR val is XORed with equal to v of I. You can also write it like this, okay. So you do this thing, okay, and after doing this thing you just simply return your XOR value, okay, and that will be your final answer, okay. So that was it, okay. Thank you.
So if you enjoyed the video, please like, share and subscribe our channel. Thank you.